So, part B of our unit on significant figures, unit conversions, SI units, and a little bit of accuracy and precision. So, unit conversions, students struggle with this. And I know in the past you guys have converted with different ways using, say, proportions and things like that. And I'm telling you, come over to my way using unit analysis, using conversion, what I call conversion factors or forms of one. So I'll go into that and then I'll show you how to do it. So, all right, so when you are converting something, let's think about mathematics here for a little bit. You are allowed to multiply anything by 1, right? So if you have the value 5, okay, and you multiply by 1, it is still 5. You're allowed to multiply by 1. Anytime you're allowed to multiply by 1, and it still doesn't change the innate value of the number, right? So what if we have suppose we multiply that same 5 by 3 over 3. All right. Isn't 3 divided by 3 a 1? Because 3 equals 3, and when you divide two things that are equal, it is a form of 1. All right, so it's a form of 1. So it's 15 divided by 3, it is 5. You're like, well, duh, yeah. Well, you're allowed to, that's a form of 1. I call it a form of 1. You have two things that are equal, divide them, it is a form of 1. So you're allowed to multiply by it. Well, this is the basis of how we're going to convert. So for instance, suppose we have 1 yard equals 3 feet. That's equal, right? I call this a conversion factor. You may multiply, if you can have 1 yard over 3 feet, or 3 feet divided by 1 yard. Those are all equal to 1, and we just said multiplying by a form of 1 is allowed. So when we have, suppose I measure my room, and the length of my room is, say, 8 yards. And I want it in feet, correct? So suppose I want it in feet. We're going to multiply by a form of 1, and I'm going to use this kind of style here to do it. So I'm going to put the fraction, this over this. Well, why did you put this over this? Well, isn't 8 yards the same as 8 yards over 1? I'm not going to put that in there, but it's this over 1, right? If you wanted to make it a fraction. And so we're going to pick one of these two. Well, one of these two makes sense, the other does not. Well, I'm going to pick this one. This is the correct one. And we'll see why. 3 feet over 1 yard. And we're allowed to multiply that by that because it is a form of 1. Remember, we are multiplying. The equal sign is outside of all of this here. It's a multiplication problem. How do we multiply fractions? Top times top over bottoms times bottom, and we're allowed to cancel because yards divided by yards cancels out. So this is 8 times 3 feet over 1, or 24 feet. That is how we do that. Okay? Let's try another one. We're going to go to another page here. This is, so I have a little bit more room. And I use things like this where I'm doing this here with it and just making it all one line. But it's the same principle, okay? So now let's try, say, 62 miles per hour. And we are going to convert it. We need a conversion factor. Suppose we want it in meters per second. So, well, you need conversion factor. 1609 approximately meters equals 1 mile, and 3,600 seconds equals 1 hour. There's our two conversion factors, and we can put these into fractions to multiply by forms of 1. We're going to have two of them because we're going to convert this one and this one. All right. Well, it does not matter which one you choose first. I'll choose miles first. Well, miles are on the top, so where do miles need to go to cancel it? On the bottom. So we're going to have 1 mile on the bottom and 1609 meters on the top. Miles will cancel. Hours are on the bottom, so 1 hour here is here, and 3,600 seconds on the bottom. So now, hours cancel, and we go top times top times top, so 62 multiplied by 1609 times 1 gives us 99758, and our units are meters, all over 1 times 3,600 seconds. And when you divide those two numbers, we get 27.71 approximately. We should use the approximately sign because I rounded, and it's meters per second. Okay. Brief little thing about accuracy and precision. Accuracy refers to how close the measured value is to the actual real value or accepted value. Precision are how close the measurements are to each other. So if you look here, accurate because you're trying to hit the bullseye. Here, this is precise because you are very consistent where you hit on the target, but you're not very accurate because you were aiming for the center. This is accurate and precise because you were aiming for the center, you hit the center, and you were consistently hitting the center. Not accurate or precise, where you were aiming for the center and you did not hit it, and you did not, you weren't consistent where you hit. We can apply that reasoning to a set of data. So our actual value here, or the known value, is this, and we did our 3 different students doing the labs. We get this, we have our data here, okay. This is very close to this. I would say this is accurate because it's close to this, and precise because they are clustered together. Okay, this data set. Okay, when you take a look here and you average the data, 1.4 plus 1.68 plus 1.45 plus 1.51, and when you take the average of that, we get 1.51. That's pretty close. So the average, I would say this is accurate, but it is not precise because the data is all over. Let's look at this one. This data is very precise because all the values are really close to each other, consistent, but not very accurate because we are not very close to the accepted value. So this one would be not accurate, but precise. Percent error is the absolute value of the error amount divided by the accepted value times 100. So there would be a good formula for you to put in your notes. And error is the experimental value minus accepted value. So if you would rather write it this way, you could just plug that into there. The absolute value of experimental minus accepted all over accepted times 100. All right, significant digits. So you are at the limitation of the device you are measuring with. Now, error can come in from not just your device. It can also come in from inherent randomness in whatever experiment you're doing. It can also come in from the messiness or sloppiness or your methods of measuring. So it's not just the device, you have those other factors that you need to worry about. So let's just talk about the device right now. You can only measure one place after the last marking. So if you look here, okay, we have, this is in centimeters. There's 10 marks in here, so those are millimeters. And so that right there is a 1/10 of a millimeter or 1/100th of a centimeter, okay? So you're going to estimate between the two, and that's the last you can do there. So you know it's 5.2, and then you can estimate the last one. So it would be 5.23. And this one is the last one that we estimated, and it's the furthest we can go. Anything, if someone said we could go over more digits out than that, it's baloney. You can't do it. You can only go to the one more place past your last known marking on your device. And even then, you're going to have some if you're not good with using your good measuring techniques, you can have some error come in even with that. Okay, rules. We're going to stop here, and we will have another one for rules of significant figures.